I'm going to talk about exercise 1105 and 1106 actually together because 1105 introduces this concept of a Z-score, which I have vaguely spoken about before because the Z-score is a number basically between -3 and +3. It measures the number of standard deviations, either above, and the Z-score would be one of the positive values. Oh, and by the way, it could be a half, or it could be even 1.3. It doesn't have to be a whole number. And the Z-scores could also be these negatives. So anything negative tells you, in terms of a Z-score, tells you you're below average. Now, it's these actual Z-scores which allow us to do a comparison between two sets of results, which is what you look at in 1106, comparing results. And you will remember me doing an example on the board where I talked about English result, maths result, average the same, having result the same. And it's not until you actually know the standard deviation or the Z-score, the standard deviation in terms of how many standard deviations your result is above the mean, that you have to know that piece of information, or you'll see how it nicely translates into a Z-score. You have to be given a Z-score before you can compare results. So it's 1105, 1106 really work hand in hand in terms of your understanding of 1105. We learn how to get a Z-score. 1106, you actually use the Z-score. So you'll hear me talk about both these ideas as we go along. So the Z-score, or sometimes, not very often now, but it was maybe about 10 years ago it might have been, that it was often referred to. Doesn't seem to want to write for me. Standardized. Hang on, I'll just pause and see why it's not writing. Okay, I've gone to a Word document now, so I think it's working okay. So filling out the notes, it says that a Z-score or a standardized score is the number that represents the position. It's the position now of the score relative to the mean. So a positive, above the mean, and negative Z-score, you're below the mean. So automatically you can see by the Z-score whether you're above or below the mean. The closer the number is to 0, the closer you are to the mean. The bigger the number in the positive direction or negative direction, and it will only be virtually up to 3 and down to -3, the further you are away from the mean. So if you want to be exceedingly above the mean or the average, so for example, maybe in the results of a test, you want a high positive Z-score. If we're talking the number of times you've or the number of points you've lost on your license, you're probably going to want to have a big negative score. You want to be well below the average in that case. You don't want to have scored the loss of too many points. So it's not always that we want a big positive Z-score value. Sometimes we want to be way below the average, depending on what the results are testing. So it just says here, a score of 1 is 1 standard deviation above. How do we know it's above? Because 1 is a positive number. If they want a negative, if they want to tell you that you're below the mean, the Z-score must have a negative on it. So a -2 is 2 standard deviations below the mean. And please don't forget, I've said you could actually have a Z-score of 1.875. Now, how you get that is out of using a formula. So the formula is on the formula sheet, so that's good. And there's an explanation of what these, Z obviously stands for the Z-score value. And it is this x minus x with a bar over it, which we know is the mean, over S. It tells you S is the standard deviation. It tells, I think that's all it tells you. You have to know that x is the score, particular score, and x with a bar over it is the mean of the scores. On our graph, this scale here equates to here 1, 2 and 3. You could have a result in here and get a Z-score between 1 and 2. Looks a little bit bigger than 1.5 even. And if that is the case, then you give the exact number that you get on your calculator for that Z-score. Have to be careful when you're doing this calculation that you bracket the top line of your calculation. You're doing more than one thing there, and it's a fraction, so please use the brackets. There is a difference between a score and a Z-score. Sometimes your score, you will clearly want to be a number bigger than 3. But Z-scores are rarely ever numbers bigger than 3. It's really outstanding. You're in that very top 0.15% of the population if you get a Z-score that is a number bigger than 3. The Z-score, so we know what a score measures. It's the value that you obtained as a result, whereas a Z-score measures the number of standard deviations that score you achieved is away from the mean. Now, it's again, when we use these Z-scores that we're able to compare data, and that's what 1106 is all about. Comparing normal distributions. A Z-score gives valuable information about a result. It tells us how far we are above or below the mean. So it takes away the size of the result. It tells us where that result is relative to the mean. And it also allows calculations to be determined for the percentage of the population below or above a particular result. So these percentages we get from our understanding of the normal curve. When a raw score is converted to a Z-score, it is known as this standardizing. So you may see it referred to as that in a question, or it might just be included in an explanation about what has happened. The results have been standardized. That means they've been converted to Z-scores. And it's only when you have standardized scores that it is possible to compare. Remember, like I said, back to the English and the maths results when we thought the average was the same, the result was the same, and we thought we performed exactly the same in the two different subjects. We saw that one of those results was quite outstanding because it was well and truly above the mean, whereas the other result was only within one standard deviation of the mean, which doesn't make it as outstanding. The other reason that we look at Z-scores is because sometimes we're asked to decide whether a distribution is normal. Now, if it is normal, you could draw the graph and see if you actually get this nice bell shape with your score here and your frequency here. What we also know about it is that the mean, the median, and the mode and are all equal. So they should all be this same score here. So if you had calculated the mean, the median and the mode and you saw they all were the same, then you can automatically conclude you've got a normal distribution. If you graph and you get the bell shape, you've got a normal distribution. Or you could check to see, and this is where your z-score and your standard deviation comes into it, you could check to see if 68% of the scores lie within one standard deviation of the mean. Now that's better explained when we do an example. I'm going to stop the video there. I will do the examples with you in class so that you feel like you're hearing this again, and I'm showing you how I expect you to set your answers out, and as an opportunity for you to ask me for any clarification of the ideas that are presented. And like I said, it's really the one concept but split over 2 exercises.